You're not hearing me?
Yes, we can hear you.
Okay. Then it's fine. Then it was just a problem of one of you. So again, welcome everybody to the third training session. We are today focusing on our product Miniforce 2. My name is Lea Wagner. I think most of you might know me. I already did the first online training session about bioprocess basics, and I'm happy that I can continue now with the next or the third session with Miniforce 2. I will try to unmute everybody so that we do not have that much background noise. And the training will be recorded for the ones that cannot attend or maybe want to rewatch it or something like that. So it will be recorded. And for questions, you can ask questions either at the end or you can write them down in the chat area during the presentation. Okay, then we will start now. So as just mentioned, we will focus today on Miniforce 2. How can I proceed? Hi Sven. Okay, first short to the content for today. We will start with sales numbers and positioning. Then we will focus on the features of Miniforce 2, the accessories, and at the end, the short summary. So let's start the positioning with a big thank you to all of you, because the numbers or the sales numbers for Miniforce look great. It's the best seller of our bioreactors, so we sell it more compared to Multiforce, Labforce, Techforce. And when it was new, we even won a gold award for the design. So we are very happy with this product, but still will continuously improving it. So yeah, let's continue together the Miniforce 2 success story. How can I do the next slide? Sorry. Furthermore, not only on the sales side we are making huge success, but also on our social media traffic has increased a lot. And here are just a few examples from LinkedIn. And I really want to thank all of you who motivate their customers to share their story and pics of Miniforce. The marketing department is very happy about this traffic generation. And yes, I'm sure they would like me to tell you, please like, share, and comment on posts, and also engage your customers to do so that we get more nice pictures like you can see here from List from Luxembourg. They have 10 Miniforces in a row with different vessel sizes. So yeah, it looks really great, and we're really happy that also on social media we have success with Miniforce 2. Now to the positioning. We had a new strategy, or added or changed a little bit the strategy some months ago. I think most of you know it. So we are now focusing on the customers in biopharma and CDMO, but still the Miniforce 2 is still a bundle for academia, so for universities, institutes, and so on. But now, in addition, we also want to focus on biopharma and CDMO as customers, especially on startups, because we think that startups are a good chance to enter the biopharma area, so that they might buy further products from us. And startups usually don't know their competition so well yet and are open to all manufacturers. So this is really a good chance to enter the biopharma area with Minifors 2. And the good news are also that Sartorius discontinued a big competitor of Minifors, the Biostat A, and this further increases our chance. Then the Minifors 2 is made for process development, so not for production, of course. And we have two versions of Minifors 2, the microbial and the cell version. And I also would like to add Eve here because most of our bioreactor customers also have Eve, which even increases our chance in biopharma because it upgrades Minifors 2. It's also for process development and can be used in GMP environment because it's qualifiable. But more details to Eve will be in session 5 with my colleague Ivo. Now to the sales numbers. So you can see here in this table our last fiscal years. So from 2020 on until now. And as you can see, we steadily increased the sales numbers. And for this year, so 2023 until now, we already sold and delivered 140 Minifors 2 and still have 67 orders open, so that are not produced yet, but already ordered. And as you can see, this year will be a new record. So because I guess we will, from these open ones, we will produce a lot of them and then have at the end maybe 170, 180. So it's a record year this year, which is very great because the sales numbers increased that much, although we have increased the prices over the last years. And also we can see here that we added now the focus on biopharma. So we have still maybe the same amount of academia customers, but added now biopharma customers, and we are the opinion that that might be one of the reasons why the numbers increased that much this year. And just to show you some of our new biopharma customers, I got some examples from our CRM. So Novartis, Evotec, Christian Hansen, they all bought Minifors 2 and are happy. So this shows us that Minifors 2 is also suitable for the biopharma CDMO area. On this slide, I would like to show you the overall customer requirements that are not requirements for the device, but basically for the process step the customers would like to do with the device. And so they are also independent from the device. So the same requirements count for shakers, also for Eve. And because the customer basically wants to have the right conditions for their processes, enough to sample. They want to have as much values as possible to know as much as possible about their process already in early state. They want to spend less money for a culture medium, have the possibility to scale up. So these are basically what the customer is interested in, and not in every screw and every technical detail of the device. We just have to make sure with our devices that we fulfill the requirements, but the detailed hardware is basically our job. And these overall requirements are, of course, optimum conditions for the bioprocesses. So we have to make sure that with our devices, they can reach the optimum conditions. Then another requirement is total cost of ownership versus customer value. So no matter that the device might be a little more expensive in the beginning, in the end, the customer still saves money because he needs less volume, has more results due to more sensors. So you always have to show the customer the whole picture and where he can save money in the end, while maybe spending a little more money in the beginning. So that the customer is aware that with the equipment he can save money, or it can save him in terms of operating costs, working time, etc. Another requirement is the reliability. So customers would like to have fast service in case something breaks, a good relationship to the distributor. Yeah, just want to have a good partner on their side. If something is not working, they get quick help. Then we have here monitoring and automation. This is for Minifors 2, mainly Eve. So there's also the touchscreen where they can, the actual or the current values can be monitored, but for Minifors 2, these two requirements are mainly fulfilled if the customer also adds Eve to the Minifors 2. And the last one is the qualification, which is not that important, or not for Minifors 2, but for many of our other products, because qualification is usually not needed in that early state. So now let's focus on Minifors 2 and how we fulfill the customer requirements with this product. So what immediately stands out is the design. It requires little space in the lab, so it has a very small footprint and is very compact, so has a great cable and tubing management, as you can see here. So everything is in one device. The vessel does not stand, or the bottles do not stand next to the device like it is for a lot of competitors, and this reduces the risk to break something, and just saves space in the lab, which again plays here in this symbol. So total cost of ownership, the customer saves money with Minifors because he saves expensive space in the lab. We have an LED status indicator, as you can see here. So the customer can see from a distance if everything is all right, then it's green, or if there is an alarm, then it's red or blinking green. So the customer can quickly see if the process is going well or not. And we have an easy cleaning for Minifors 2. So there's a stainless steel tray for small spills. And also, as you can see here, the vessel holder is hovering a bit above the base, so that spills can be wiped easily. Now to the usability of Minifors 2. Since it has such a compact design, the transport to and from autoclave is very easy, so everything can be attached to the vessel holder, as you can see here. So the bottles can be attached with the tubes, and the pumps are attached, so everything can be brought in one as one vessel or vessel holder to the autoclaves. And the Minifors 2 in this way even fits in smaller autoclaves, which again saves maybe money for the customer, because he can use an autoclave he already has, or can buy a small autoclave. And since we are using a heating block, as you can see here, for tempering, the vessel is also very light, because we do not have a double wall vessel. And it also saves time after autoclaving, because you don't have to fill up the jacket with water and so on. So with the usability, we improve the workflow of the customer, and there are less risk for errors. Now to the design of the vessels. We have a round flat bottom, as you can see here, and a clear top plate layout. It's very suitable. It's suitable for microbial and for cell culture and brings very good results. We also have process data. I will show you later on in more detail, but KLA, power input, oxygen transfer rate is very good with this vessel geometry. Moreover, the motor is placed a little higher, as you can see here, so that the ports can be accessed easily, and there's also, compared to our competition, more space for ports. So here are the details. We have up to 7 12mm ports, which allow the customer to add several sensors. So not only pH and PO2, but maybe also biomass, viable cell density, redox. I will present you all the sensors later on. So and these are the advantages, or fulfills the requirements for optimum bioprocess conditions. So because we have a great vessel geometry and vessel design, and also total cost of ownership, because we offer more ports compared to some of our competitors, and the customer gets more values from the sensors, so saves in the end time and money, because he might need less experiments. The vessels can also be changed easily. So between the 3 different vessel sizes, we have 1.5 liters total volume, 3 liters and 6 liters total volume for Minifors 2. And the changing of the different vessel sizes takes less than 10 minutes because it's very easy. You just have to remove and exchange the heating block, of course, because the vessel will be smaller or bigger, and then the customer can select the new vessel size on the touch screen, and all settings are automatically set. So this saves the customer working time, and less equipment is needed, because the customer can change between vessel sizes by themselves and does not need the service to come to change configuration, but everything is set automatically. Now to the pumps. We have 4 high precision pumps at Minifors 2, which are flexible, which have a flexible configuration. So as you can see here on the screenshot, first the customer can choose between 3 different tube types, depending on the flow that is needed. So a small tube diameter for small flows, and for higher flows, the customer can choose bigger tube diameters. And also, this is what I meant when I said flexible configuration. The feature, or the job of the pump can be changed. So maybe if the customer does not need anti-foam, for example, because the cell culture does not create a lot of foam, or does not need acid because the customer has maybe carbon dioxide instead of acid, then the pump can be reconfigured as feed pump. So can be switched from fixed speed to variable speed, and this allows the customer to have an additional feed pump and to do, for example, more complex fed batch or continuous culture processes. Moreover, the 4th pump, so the feed pump, can be changed to gravimetric feeding if the customer buys a balance and connects the balance to Minifors 2. And then not only milliliter or milliliter per minute can be chosen as unit, but also grams per hour, which is a little more accurate. And there's also a dose mode available, which means that the customer can add, for example, 100 grams of glucose and then stop pumping. So a one shot of feeding. And in case the customer would like to have more complex feeding strategies, so for example exponential feeding, then these strategies can be used when having Eve. So then the customer can also use more complex feeding strategies, more maybe also for a continuous culture. Another advantage of these pumps are that they are autoclavable. So they, as showed before or mentioned before, the pumps are attached to the vessel holder during autoclaving. So everything is sterile afterwards, and all the tubes are already connected to the right pump heads. They are also labeled, so to reduce the risk for errors here. And then the plate with the pumps can be attached to the controller, and the pumps can be primed automatically. So before each process, the customer needs to fill the tubes of the pumps and up to the top plate, so that the controller is not confused by pumping in only air. And after the process, the tubes are emptied for autoclaving, and this the customer does not have to do this all manually, but can, as you can see here in the screenshot, choose a filling or emptying duration, and then can prime the pumps automatically and in parallel, so not one after the other, but maybe can fill them for 20 seconds, all pumps in parallel, and then do the fine tuning manually. So this saves money, saves time at the end, and improves the workflow of the customer. We have a relatively new exit gas cooler against evaporation in the process, so to keep a constant concentration inside the vessel. The exit gas is cooled down in the exit gas cooler. So the old version was a compromise between good cleanability and performance, and the new one is now better in both aspects. So the gas flow pattern was improved, which allows a more efficient removal of the moisture from the exit gas, so no filter blocking at the end. And as you can see here, the new baffles are made out of silicone, and the exit gas cooler can be opened. The silicone baffle can be removed and cleaned. So it's very easy and very good to clean compared to the usual exit gas cooler, which are closed and made from stainless steel, and the baffles cannot be removed. So this is a big advantage compared to most of our competitors. So on the next slide, I would like to focus on the touchscreen controller. The touchscreen controller is optimized that also customers that do not have used a bioreactor so far can easily operate a Miniforce 2. One example is the easy calibration wizard. So everything is described in detail, so the customer just has to do one step after the other and gets at the end a good calibration. And it's also the same no matter if the customer has Hamilton or Mettler sensors, and for long running processes the customer can also do pH product calibration. So through this wizard, this calibration wizard simplifies the handling, and the customer gets more accurate results, because if something goes wrong during calibration, the results of the bioprocess are at the end basically worthless, because the sensor measures not the right value. So it's very important, the calibration step, and we made it here as easy as possible with a very low or no risk for the customer of doing something wrong. Another cool feature of the touch controller is the application optimized gassing, which is standard. So the customer can choose from pre-configured cascades for PO2 control, also for pH control basically. But here you can see for oxygen control. So the customer has a certain set point for the oxygen and then can choose in which order he would like to change the values. So for example, for this example, if the oxygen concentration goes too low, first the stirrer is increased. When the stirrer reaches the set maximum, then the total flow is increased, and then at the end the gas mix. So depending on the application of the customer can choose maybe for more sensitive cells to first increase the gas mix and later on the flow and the stirrer. So has the chance to change the oxygen control depending on the application, which makes the Minifors 2 a very, very flexible product that can be used for different applications and processes. And also, if the customer is a little more experienced, the customer can change the PID settings for oxygen, but also for pH, for example. But yeah, we chose some standard PID settings which work well for most of the bioprocesses, but to be more accurate, or if there are different processes, the customer has the chance to change it, but also to reset it at the end if it's if it's worse than before. So with the touchscreen controller, we allow the customer to get optimum conditions for the bioprocess. The customer can monitor the current value and also see if there is an alarm and which alarm and so on. And also in the end saves money because he gets more accurate results and can use Minifors for different applications. As mentioned in the beginning, we have two versions of Minifors 2, the microbial version and the cell culture version. They have the same vessel geometry and the same vessel sizes, so from 1.5 liter total volume up to 6 liter total volume. Yeah, they have the same, as just mentioned, the same vessel geometry, but of course the two versions still have differences. So we have different impellers, for example. Here for the microbial version you can see two Russian impeller, whereas the cell culture version has only one big marine impeller due to less shear stress. I explained this all in more detail in the first session, why we have these different configurations for microbial and cell culture cells, and why the cell culture cells are more sensitive and so on. And this is also why we do not have baffles for the cell culture version, but for the microbial version. Yeah, and of course also the stirrer speeds are different, and also the gassing is different because they have different needs. So the gases I will show you on the next slide, or the next slides. So the version for microorganisms has a 2 gas mix as a standard. So there are two mass flow controllers, 2 MFCs are integrated, and the customer has the choice to operate it either with only air, with air and oxygen, which is perfect for high cell density because yeah, if there are more cells, you need more oxygen. You can increase the oxygen content inside the media by increasing, for example, the gas mix. And there's also the option to operate it with air and nitrogen, which is not that often, and it's because it's for anaerobic processes, so for microorganisms that do not need any oxygen. Yeah, And this is a very high standard because we have MFCs as standard. So most of the competitors just have rotometers and magnetic valves. But yeah, with the MFCs, the customers get more accurate results, and usually also during scale up, rather MFCs are used than just rotometer and magnetic valves. So this makes the scale up more easy. And the gassing also has a safety feature, so there's overpressure detection and shutoff in case the exit gas filter blocks, for example. Now to the gassing for cell cultures. So they have different needs. This is why they need more MFCs, so they need more different gases. So we have 5 MFCs in the cell culture version as a standard. There are MFCs for air, oxygen, and nitrogen for the gas mix, because you also need nitrogen to lower the oxygen concentration, because a too high oxygen concentration is toxic for cell culture. We have an additional MFC for headspace gassing to avoid foam formation. And there's a 5th MFC for carbon dioxide, which is often or mostly used for pH control for cell culture processes. So instead of acid, because acid harms the cells. So for cell culture, the customers rather want to use carbon dioxide for pH control. That can be used either in headspace or through the sparger. And of course, also for this version, we have the overpressure detection and shutoff. So this again fulfills the requirements of the customers to get the optimum conditions for their bioprocesses, and also total cost of ownership, because we have a very high standard here with MFCs instead of rotometers and magnetic valves. When we developed the cell culture version, I think it was around 4 years ago, we made a performance study together with the Zurich University of Applied Sciences. And this performance study includes an investigation of the process relevant parameters, but also a real process. And there we chose the process transfer from shaker to bioreactor, which is a process that is often done at the customer sites. And to this topic, we have an application note available in the member area or on the website, and also a blog post on the website if you're interested in more details, but I will also explain it now on the next slides. So let's start with the investigation of process relevant parameters. There are 3 parameters that are especially relevant also later for scale up, which is the mixing time. So how well is, for example, the feed or pH, like acid base and so on, mixed when it is dropped inside the vessel. So how fast is it spread in the whole media. Then the gas transfer is important, because the gas transfer, or Cal-A or oxygen transfer, describes how well the oxygen is transferred from the media, from the gas into the media. So this is important because it describes how much oxygen is available for the cells. And the power input. So as you can see here on these CFD pictures, we tested different impellers. So if we get better results using, for example, 2 little marine impellers, which have some of our competitors, or 1 big marine impeller and downwards or upwards. And with this tool, we can see here the little white arrows show the mixing. and the brighter the blue in the background, the more shear stress we have. So we tried to find there the best balance between mixing and shear stress. And here you can see how the mixing time was measured. So some solution was dropped inside the vessel so that the blue color clears, and then the time was measured how fast the media got clear, and this described then the mixing time. So we saw with the process relevant parameters that in theory the bioreactor is perfect suitable for cell culture, but of course we also want to prove this with a real cell cultivation. And there, as I mentioned, we did a process transfer from shaker to the bioreactor. So we started in the shaker with multitron, with the screening. I'm sure that Daniel explained that in more detail in his presentation in session 2. So maybe with 3 millimeters or also bigger shaking throws, the customer chooses the best clone, for example. And then when the customer found the best clone, the next step would be to transfer the process into a bioreactor. So to change from shaking to stirring and gassing and so on, which is not that easy because it's something completely different. And we did it with the following conditions. So we used CHO cells. It was a batch cultivation, so no feeding. The CHO cells produced IgG, so an antibody, and the transfer was from a 250 ml Erlenmeyer flask to the 1.5 liter Minifors 2 cell version. And we got these results, as you can see here. The black dots and squares are the shake flask, the white dots and square are the Minifors 2 cell, and the dots are the viable cell density and the squares are the antibody concentration. And as you can see, we got the black are the shaker and the white bioreactor, and we got better results in the bioreactor for the viable cell density and also for the productivity. So these are very good results, and they prove that the Minifors 2 cell version is perfectly suitable for cell culture. Yeah, and if you like to see more details to the process, or you have customers that ask for more details, then you can also always give them the application note. So you can see them here. We also did the process engineering characterization for the Minifors 2 microbial version, and it includes also a high cell density process as an example. And as just mentioned, for cell culture, we also have there the CalA OTR, but also the process transfer from shaker to bioreactor. So you will find more details in the two application notes on either the member area or the website, so you can find it on both. On the next slides, I would like to focus on the biggest competitors for Minifors 2. One of the big competitors, as just mentioned from Sartorius, is discontinued, but there are of course others. So we have BioFlow 120 from Eppendorf, for example. As you can see here, the device is less compact, so the vessel is standing next to the controller, and also the bottles there are not shown here, but they would also stand next to the main to the controller. So we have a much bigger footprint, and there's also the risk of tipping, for example, a bottle, or get caught in a hose and break something. So this is the cable and tube management is much better at Minifors 2 compared to the Eppendorf device. yeah, here you can see it again on this picture. So we also have the advantage, as mentioned before, that everything of a great usability, because the whole device or the vessel can be brought to autoclave together with the bottles and also with the pumps. And for Eppendorf, you do not have attached everything to the vessel, so there are different parts that somehow must be transported to the autoclave, and the customer needs to reassemble tubings, etc. again after autoclaving. So with Minifors 2, the customer saves time and has less risk for errors. And here are more some features compared. So for Minifors 2, we have 4 pumps as a standard, and there are additional pumps. For example, Watson-Marlow pump possible. For Eppendorf, there are only 3 pumps as a standard, and for Eppendorf only offers connectivity to Mettler sensors, but we also offer the possibility for the customer to use Hamilton sensors instead of Mettler. We have the possibility to add a biomass sensor and many more sensors. I will mention them in the accessory part, and also have this LED status, which is not visible here on this device. For more details, for further details, for the comparison of these 2 devices, you can go to the member area, and you will find there a competitor overview with more competitors and also more details to the comparison. But I want to mention one more competitor, MyControl from Getinge, formerly Applicon. The footprint of the MyControl is smaller. It looks smaller here, but basically it's bigger, because it's the footprint that they give is only the controller part, but not the vessel part. So all in all, the MyControl has for sure a bigger footprint compared to Minifors, and we have again there the advantage that we have one compact device and they have like 2 separate parts that are connected with cable and hoses and so on. And the risk that something breaks or it just does not look as neat and clean as Minifors 2. And also for these 2, or for the comparison of these 2 devices, you can find more details in the competitor overview in the member area. So now the next part, I will focus on the accessories that can be added to Minifors 2 as an option. We offer rather new sensors. I don't know if you all saw the webinar to this topic, but there is now the possibility to add more Hamilton arc sensors in combination with Eve. There are 3 new sensors. First, Hamilton Inside Arc that measures the viable cell density in the bioprocess, which is especially for cell culture a crucial parameter, because it shows how well the process works for the cells. Because if many cells die, maybe the slivering speed or something is too high and the cells are destroyed. So it's an important parameter to find the right process conditions. Then we have the Hamilton Density Arc, which measures the total cell density based on the optical density in the media. So it's basically like the Optec sensor, but the Hamilton sensor only has one sensor with one optical path length. So for Optec, we have 3 different ones depending if the customer has high or low cell densities. But for Hamilton, they found a solution that only one optical path length can measure all cell concentrations. And the third one is the Hamilton control arc, which measures the dissolved oxygen concentration, which is also rather important for cell culture processes and not necessary for microbial processes. There are different ways to set up the sensors with Eve and the device. The first possibility is to have one box. So what is needed to have the solution is the customer needs Eve and the OPC driver with UI, and also a so-called ARC Modbus OPC converter, which is a little small box from Hamilton. And to this box, up to 4 Hamilton ARC sensors can be connected. So, for example, if the customer has 4 Minifors 2 and wants to have an inside ARC in each Minifors, the customer can buy one box and then connect 4 inside ARCs to this box. Or another possibility would be, for example, the customer has 1 Minifors and want to have up to 4 different Hamilton ARC sensors inside the Minifors, or maybe has 2 Miniforces and want to have density and control in each one. So there are several possibilities to use the box, and all of these articles, so of course Eve, but also the UPC driver with UI, and also the ARC Modbus OPC converter and the sensors, they're all available in the configurator. So the requirements the customer needs is the newest Eve version. The customer needs to purchase OPC driver with UI, and the black converter box, and of course the cool sensors. So you can see here in the configurator we have the inside, the biomass sensor, and also the carbon dioxide sensor available. So these are all parameters that most of our Minifors 2 competition cannot offer. So we are very happy that we have now the possibility via Eve to also offer these parameters, or to monitor these parameters online. So this is a big advantage for the customers, to find the optimum process conditions. Then, as a standard, there's always pH or redox and an PO2 sensor in the Minifors 2. So this is standard. The customer can just choose between Hamilton and Mettler, or a mixture of both. The Hamilton ARC system in general has a digital connection, which has the advantages that there's no loss of signal quality. The sensor health can be monitored, and the calibration status, and also the calibration data can be stored inside the sensor. So before the customer starts the process, the customer can see if the sensor still has a good quality or very low quality, and then has the chance to exchange the sensor before it breaks, maybe during the bioprocess. Which is a big advantage, because if the sensor breaks during the bioprocess, he has to restart, and this is a waste of money and time. So this is a big advantage compared to analog sensors. And the Hamilton oxygen sensor, of course, is also digital, and it's also an optical PO2 sensor, which means that no electrolyte and also no polarization is required. And this saves time, because usually polarization takes around 6 hours. So this is valuable time the customer can save by using an optical PO2 sensor. And as an option, also a redox sensor from Hamilton is available instead of the oxygen sensor. As mentioned before, we also have the Mettler ISM sensors available. These are also all digital sensors with all the advantages I just mentioned. And it's also an optical PO2 sensor. So also for this PO2 sensor, no polarization is required. There are many more options and accessories that can be optionally added to Minifors 2. As mentioned before, an external balance can be connected for gravimetric feeding. The available balances are also all in the configurator. There are 2 from Cairn and 2 from Mettler available. And with this balance, the user can use gravimetric feeding, and in combination with Eve can do very complex feeding profiles, for example, an exponential gravimetric feeding, or other feeding profiles for continuous or fed batch culture. There's the possibility to also add a biomass sensor. So the turbidity of the medium gives an indication of the biomass concentration, and if with the biomass sensor the customer can continuously monitor the biomass, so the customer can react faster to changes, and there's also less risk for error compared to manual biomass measurement, which is usually only maybe every 6 hours. So the customer gets more insight in the bioprocess by continuously monitoring it. And besides the density and Eve solution I just mentioned, there's also the Optex sensor available, and for the microbial version also the BioR, which is attached outside the vessel, so the customer saves another port. Then we have an exit gas analyzer available from the manufacturer is BlueSense, and we have the Blue-in-1 and the Blue-Very in different combinations depending what the customer needs, or if the customer has cell culture or microbial process. And with the exit gas analyzer, gives the customer a hint of the about the metabolic activity of the process. Deeper insight in the process, and in combination with Eve, the oxygen uptake rate can, for example, via soft sensor can be calculated, or the carbon evolution rate and the respiratory quotient, which gives the customer deeper insight into the bioprocess. And last but not least, we also have 2 analog inputs/outputs for more external sensors and devices. I will show you on some examples on the next slide. So the analog input/output uses 4 to 20 milliampere signal, and the input can be used for additional external sensors. So for sensors we do not offer, maybe the customer want to add a sensor to measure metabolics, like lactate or glucose concentration. The input/output can also be used for external devices, for example, an external pump. We offer the one from Watson-Marlow, or also to connect, for example, an external perfusion system to run a perfusion process on Minifors 2. So all these accessories basically again fulfill the requirement of optimum bioprocess conditions, of course, because the more values the customer can monitor online, the better he can control the process. And the more he knows about the process, the easier he can scale up the process, because in bigger volumes you usually also have more sensors. And the total cost of ownership, because it might be a little more expensive in the beginning to add more sensors and external devices, but in the end the customer saves time and money, because he has a better insight in the process, and also faster can also optimize the process faster and saves working time. Another accessory, I would not call it accessory, for Minifors 2 is Eve. So they work perfectly together. Eve upgrades the Minifors, and the requirements that biopharma has are fulfilled if Minifors 2 is combined with Eve. And we also often hear from your sales colleagues that they use Eve as a catcher. So when they are in a sales talk or at the customers, they first show the customer Eve and all the cool features, and then later on continue with the hardware, but basically convince the customer with the software. Eve connects to the customer network. The communication is based on OPC UA. You can plan, monitor, and control. Can do batch planning and so on. I don't want to go into detail. I'm sure that Ivo will maybe also give you a live presentation of Eve, and you will see all the nice features if you don't know them already. And also additional information can be synchronized, like the time of inoculation, the offline sampling, and at the end everything can be printed as a report, and the audit trail allows the customer to log all the events. So I'm almost at the end, but I come back to this. Want to come back to this first slide at the beginning with all the customer requirements. So these are the requirements, the overall requirements, independent from the device. And now I want to show how we fulfill them with our bioreactors, or what is important for the customers, especially in the process step of using a bioreactor. So optimal conditions for bioprocesses, there it is important to be able to integrate as much peripherals as possible. And as I just show you with the accessories, we have the possibility of to integrate a lot of different peripherals, depending on the process of the customer. The device should have design that gives optimal conditions for bioprocess, so the Cal-A gas transfer, mixing, and so on. I showed you before, and also there we have good results for Minifors 2, and also it also improves the workflow, like the bringing the device to the autoclave, and also the setup is very easy, so the customer can unpack the device and basically start right away. So saves money, saves time there, and improves the workflow. Smarter controllers is maybe not the focus of Minifors 2, but already the cascades show that we have features also in the area of smarter controllers, also in Minifors 2. Then the qualification, as mentioned before, is not the focus of Minifors 2, but there for bioreactor customers, a complete reporting would be important. So for Multiforce, Labforce, TechForce, we have the possibility of qualification. Then monitoring and automation is primarily fulfilled with Eve. So the process parameters can also be monitored, of course, only with the touchscreen, but kinetic figures like the respiratory quotient I mentioned, like all the soft sensors, they are together with Eve. Here you see soft sensors, and also batch planning is available if the customer combines the Miniforce with Eve. Then we have total cost of ownership versus customer value. There it is important that the device is scalable, so that scale up is easy, or to integrate it in a scale up procedure. This is also given with Miniforce 2 because we use usual, for example, height to diameter ratios. It has a suitable scale, so it's not too big, but also not too small to save medium costs on one side, but on the other side also have enough to sample. It is convenient, so the usability is great. The workflow, so here we are very good with Miniforce 2 and open connectivity so that it can be integrated in other software. So this is not the focus for Miniforce 2, but for the other products. And for the reliability, we offer a fast service. So we mostly get the feedback from our customers that our service and partnership is great. So this is something that can be also mentioned in a sales, in a customer or in a talk with the customer, that we offer great service and fast respond. And self-check is also not for Miniforce, but a requirement in general for bioreactors. Now, I'm at the end of my presentation. We'll just do a very, very short summary. So I just already summarized the features and the requirements that we fulfill with them. But I also want to mention again the positioning that Miniforce 2, because there are some people hesitating that maybe Miniforce is not good for biopharma CDMO, and you are only allowed to sell it to biopharma. This is not the case. You are still allow, of course, to sell it to academia customers like university institutes, professors. But now it's also the focus, and we also invite you to sell it to biopharma CDMO area, especially to startups there, as a chance to enter the biopharma area. This is something I just want to mention again, and also that Eve is a great product and can be used as a catcher in a sales talk, and always upgrades Miniforce 2 and makes it suitable for biopharma, as we know, because we already have big biopharma companies in our customer. So Novartis, Evotec, for example. This is just a message I want to give you again at the end of my presentation. So then basically that was it. I hope I was not too fast for you. Thank you for your attention. And if you have any questions, you can now unmute yourself and ask them, or maybe there are also some in the chat area. I did not check it in parallel, to be honest. So there are no questions in the chat area. So if you have any questions right now, please unmute yourself and I will try to answer them. No questions?
No, thank you very much. It was very good and informative.
Thank you. And if you don't have any questions right now, feel free to always contact either your ASM or contact us for further questions. We will be happy to help you anytime. So, yeah. Okay, if there are no questions, it's also okay. Then we are finished earlier. And yeah, nice to see you all again. And I hope some of you will come to the on-site training next year. Yeah, besides that, have a nice day. And yeah, see you soon.
Thank you very much.
You're welcome. Bye.
Bye.